So we are still on application of the torsion equation. Let's consider the question on the board. It says a solid circular shaft of 10 millimeter diameter is transmitting 100 kilowatt at 150 rpm. Question says find the intensity of the induced shear stress in the shaft. Okay, so recall. Okay, let's get down the given parameters. We were given that the diameter is 100 millimeter. So diameter D is actually 100 millimeter. So we can always convert this to meters simply by dividing through by 1000. And if we do that, we are going to simply obtain that D is actually 0.1 in meters. Okay. Next is transmitting 100 kilowatts. So power was given to us. Power P equals 100 kilowatts, which we can actually convert to 100. Kilo means by 10 to the power of 3 watts. So that becomes the given power. Okay. 100 kilowatts at 150 rpm. So the speed of revolution, speed N was given simply as 150 rpm. So we have 150 revolutions per minute. The equation is asking us to find the shear stress induced in the shaft. So we are to look for the shear stress, tau, which is actually unknown. Okay, we are to look for the shear stress. And to do this, recall from the torsion equation. We simply have that torque all over J, second polar moment of inertia, is equal to G theta all over L, and that's also equal to the shear stress all over the radius R. Okay, so all we need to do now is cross-check the given parameters and compare them to the formula. Any one that matches will work with the two. Okay, here we have diameter, and we are asked to find shear stress, and this is where shear stress is. Of course, if we know diameter, we can find radius, so automatically we are using this equation. And when given the modulus of rigidity and when given the angle of twist, so which simply means we can't use this equation. Okay, we need to find the polar moment of inertia. Of course, if you know the diameter, you can find J, and then we are given power, so which means we can also find the value for the torque. So we're actually going to use these two equations, this and this, to solve this problem. So using T all over J equals shear stress all over R, and the equation is asking us to find shear stress, so which means we can actually make shear stress subject. If I cross multiply here, radius multiplied by the torque, that will give me the value for the shear stress, and shear stress is simply radius times torque all over J. Okay, so what then is the radius, what then is the torque, and what then is J, which is second polar moment of inertia? So from diameter equals 0.1 meter. Okay, we can actually find radius. This implies radius is actually diameter all over 2. So this simply means that radius is actually D 0.1 divided by 2, and therefore radius is actually 0.1 divided by 2, 0.05 in meter. Please confirm this. That gives us the value for the radius. Next is to find the torque. We were given power. We were given the value for power 100 kilowatts. So recall that power P is actually 2 pi nt all over 60,000 when the power is in kilowatts. That's the formula. So all we need to do is simply make T here stands for the torque, N is the speed of revolution, of course 2 pi is the angle of revolution, which is actually in radians. Okay, so we'll simply make T subject of the formula. If we make the torque T subject, we are going to obtain 60,000 P all over 2 pi, and so that simply gives us the value for the torque. Okay, now take note, it is 60,000 because power is in kilowatts, so which means we're actually going to be working with 100 kilowatt and not 100 by 10 to the power of 3 watts. Okay, please take note of that. This is the formula for power. When the value of power is in kilowatts, simply divide by 60,000. So we've already done the conversion here, the 1000 division here, okay, for kilowatts. So if you're using only 60, that's when you can use power in watts. So we use this formula when power is in kilowatts, which simply means we are not going to convert the power. So we are not going to make use of this particular part of the power, which is 100 by 10 to the power of 3 watts. We only use 100 kilowatts because it has already been converted here, and this is formula for power in kilowatts. Okay. Therefore, torque becomes, this is now equal to 60,000 multiplied by power is 100 kilowatts. So simply 100 all over 2 by 3.142 by n. N is the speed of revolution, and the speed of revolution was given to us in the equation as 150 rpm. So simply multiply by 150 by 150. Okay, so torque T is now equal to 60,000 by 100, simply gives us 60 1 2 3 1 2. Okay, that's about 6 million. Okay, all over 2 by 3.142 multiplies 150. 942.6. Okay, so 6 million divided by 942.6. This simply implies that the torque T is equal to 6 million divided 942.6. 636.6365.37 newtons meter. So this gives us a value for the torque. Okay, having found the torque, the only thing left is to find the second polar moment of inertia, J. Okay, so J itself is actually pi times diameter 4 all over 32. That gives us the value for the second polar moment. Okay, so this is now equal to pi remains 3.142 multiplied by diameter. Diameter was given to us simply as 0.1. So we simply have 0.1 all to the power of 4 divided by 32. Okay, so J is now equal to 3.142, okay, multiplies 0.1 to the power of 4, 1 times 10 to the power of minus 3. 0 minus 4, 0.1 to the power of 4, okay, 1 times 10 to the power of minus 4 all over 32. J is now equal to 3.142 multiplies 1 by 10 to the power of minus 4. 3.142 by 10 to the power of what? Minus 4. Yeah, divides 32. Okay. So we simply have J to be 9.82 by 10 to the power of minus 6 in meters 4. So this becomes the second polar moment of inertia, J. So we've obtained J, we've obtained the value for the torque T, of course, and we've obtained the value for the radius arrow. Okay, we've obtained radius arrow, so we can simply now substitute that equation, those values, into the given equation for shear stress. Simply radius times torque all over second polar moment of inertia. So let's do that over the other side. All right, so shear stress is simply radius times torque all over J Okay, so let's plug in their values. Radius gave us 0.05. Shear stress equals, in place of radius we had 0.05 multiplied by the torque. Torque actually gave us, okay, here torque gave us 6365. So we have 6365.37 all over J, and J gave us 9.82 by 10 to the power of minus 6. So simply 9.86 by 10 to the power of minus 6. Okay, sorry. That's 9.82 by 10 to the power of minus 6. So shear stress is equal to, so give me 0.05 multiply 6365.37. That gives us 318.27 all over 9.82 multiplied by 10 to the power of minus 6. Okay, so this implies that shear stress is equal to 318.27 divides 9.82 by 10 to the power of minus 6. Okay, that gives us 324,103.86.97 newtons per meter squared. So we can actually approximate this simply moving this decimal place into 6 places backwards. Simply moving this decimal point 6 places backwards. 1, 2, 3, 4, 5, 6. So that simply implies that we can call the shear stress to simply be 32.41 meganewtons per meter squared. All right, so that becomes the value of the shear stress transmitted into the transmitted by the shaft. All right, guys. I hope you find this very interesting and helpful. Please, if you do, don't forget to share your thoughts in the comment section. And of course, if you're new to the channel, please do well to hit the subscribe button to keep getting updates on contents as this. I will see you in the next video with more problems. Thanks and cheers.